Welcome to Ask and Learn.
So we want to find values of k that satisfies this differential equation here. So we know we need our regular y equation, which we already have, but we also need to find our y double prime equation. So we're going to take the derivative of this function here. But first we need to remember that the derivative of cosine is negative sine, and the derivative of sine is positive cosine. So we're going to use those identities when we take our derivatives. So y prime equals, so using chain rule, we take the derivative of the outside, so cosine changes to negative sine, and we leave the inside the same, times the derivative of our inside, which is k. So we simplify this. Now we need to find our y double prime equation, and remember that k is a constant, so we're still using chain rule, not product rule. So we take the derivative of the outside, so that's going to be negative k cosine, leave the inside the same, and times the derivative of the inside. So we simplify this into that. So we're going to use all three of these equations, and we're going to plug those into our differential equation here. So we have 4 times our y double prime equation, which is negative k squared cosine kt, and set it equal to negative 25 times our original y equation. So after distributing, we're going to get this. And we can add 25 cosine kt to both sides. So we're going to have 25 cosine kt minus 4k squared cosine kt equals 0. And we want to pull out a cosine kt. So we're left with 25 minus 4k squared on the inside. And whenever we're left with these two factors, we're going to set what's inside the parentheses equal to 0. And we're going to solve for k. So k equals 5 over 2, but it also equals negative 5 over 2 because it's a square root, so we can't forget about that negative there. So these are our k values, and we're going to need these for part B. So part B asks us to verify every member of the family functions. So y equals a sine kt plus b cosine kt. And want to verify that it's also a solution of the y, 4 times y double prime equals negative 25 times our original equation of y. So we're going to use our values that we found in part A for k. So first we're going to plug in, we're going to say k equals positive 5 over 2. So I'm going to plug that into our original y equation. And we still need to be able to use this equation here, so we need to go all the way up to y double prime. So first let's take the derivative. So a is a constant, so still using chain rule, take the derivative of the outside, sine goes to cosine, leave the inside the same, times the derivative of the inside, which is 5 over 2. And do the same thing here. B is a constant, so we're going to take the derivative of the outside. Derivative of cosine is negative sine, leave the inside the same. This is going to be negative b sine, times the derivative of the inside, which is 5/2. So we simplify this into this here. And to find y double prime, we're going to do the same thing. So we take the derivative of the outside, which is negative sine leave the inside the same, times the derivative of the inside, so we're going to multiply it times negative 5 over 2. I'll put parentheses here. Do the same thing here. So we're subtracting, take derivative of the outside, derivative of sine is cosine, leave the inside the same, times the derivative of the inside, so we're going to multiply by 5 over 2. And we simplify this into negative 25 over 4a sine 5 over 2. And same thing here, negative 25 over 4b cosine 5 over 2t. So now we have all the equations that we need to plug into our differential equation. So we're going to use these, and we're just going to substitute them in. So we have 4 times our blue, which is our y double prime, and we set that equal to negative 25 times our original y equation. I don't think this all will fit on one line, so I'm just going to, hopefully it'll fit. Yay. So now we distribute, and we're left with negative 25a, just distributing that 4 into our left-hand side. And now I'm going to distribute this 25 into our right-hand side. And our left-hand side is exactly what's on our right-hand side. Therefore, we verified that solution for the value of k. However, we need to do the same thing for when k equals negative 5 halves. So we still have the same y equation. So y is going to equal a times sine of negative 5 halves t plus b times cosine of negative 5 halves b t. And we still want to use the differential equation. 4 times y double prime is equal to negative 25 times our y equation. So we're going to do the same thing here. We're going to take y double prime. So first to find y prime. So take the derivative of the outside, leave the inside the same, times the derivative of the inside, which is negative 5 over 2. Do the same thing here. Our derivative of the outside is negative b sine, leave the inside the same, times the derivative of the inside, which is negative 5 over 2. So all that's just positive. So if we simplify that, we'll have this here. And for y double prime, we'll have we're going to take the derivative of the outside. So that'll give us a positive 5 over 2a sine. Leave the inside the same. But now we multiply by the derivative of the inside, which is negative 5 over 2. And then same thing here. So we have 5 halves b, take the derivative of the outside, that goes to cosine. Leave the inside the same, times the derivative of the inside, which is negative 5 halves. So if we simplify this, we'll get positive 25 over 4a sine negative 5 halves t minus 25 over 4b cosine negative 5 over 2t. So again, these are the equations we're going to use to plug into our differential equation here. Was given. So we have 4 times our y double prime equation. And for our right-hand side, we'll have negative 25 times our original y equation. So now all we have to do is simplify by distributing. So we'll have this here. Is equal to negative 25 and distribute that into our right-hand side. Okay, I made a mistake because we have a negative here and a positive over here. They should have the same sign, so let's see where I made the mistake. Okay, the derivative. Let's look at our y prime. Sine to cosine is a positive times that negative, that's negative. Cosine to sine is negative times that negative, that would still make it positive. So simplify that, right? So let's look at our y double prime. We have cosine to sine, that would be a negatives, which would make the whole thing positive times our negative inside. So this is actually a negative here. So that would be negative here. That would mean this would be negative 25 sine A. So since our left-hand side is exactly equal to our right-hand side, we have verified this value of k also.